Welcome to class, everyone. Today's topic is 7th grade mathematics, algebraic equations. So first, let me introduce our schedule for today. Today's schedule, first, we're going to go over single variable linear equations. So a lot of you know how to solve these already. This will be a review and also some new material for some of you. So please pay attention to this first part. The second part, we're going to go over identity equations and no solution equations. And third, we're going to be doing rearranging multivariable equations. And this is some very useful material, so please pay attention during the class. So let me go over linear equations first. Now, in linear equations, we have something called a variable. And a lot of you know what a variable is, but I'll still go over it for students that do not know. Okay, a variable is a symbol that denotes an unknown number, okay? Could be X, could be Y, could be any symbol, could be a star even, could be a star. Okay? It is just a symbol that denotes an unknown number. And the definition of a linear equation is an equation containing variables, numerals, and an equal sign. Okay, so let me give an example. So 2x plus 4 equals 2. Okay, so does it have variables? Yes, check. Does it have numerals? 4 and 2? Yes, check. Does it have an equal sign? Yes, check. So that is a linear equation, okay? And has to have an equal sign, okay? It is an equation, not just an expression. So, let me introduce another example. 1 over 4th times the quantity of x plus 4 equals 2 plus 5. Okay, 2 plus 5x. Okay, so this is another linear equation. So let's see. Use red. Where are the variables? Okay, we have our variables right here and here. Okay, and then we have our numerals. Okay, just a bunch of them. And then we have our equal sign. Okay, so this is a linear equation. Okay, so now that I've given a few examples and I've gone over the definition, could you guys please come up with some examples of linear equations yourselves? So please come up with some examples of linear equations in the chat. Please put them in the chat. So who can come up with a good linear equation example? Okay, Jerry says a plus 2 equals 4. Very good, Jerry. And Steven says 1 plus 2 equals f. Very good. Okay, very good examples. Does anybody have any more examples? Okay, Jocelyn says y plus 2 equals 7. Very good. And Oliver says 6x squared plus 7 equals 17. Very good. Okay, and I'm sure there'll be a lot more examples. Okay. Now that we've done a few warm-up exercises, I'll move on to how to solve linear equations. So, remember I told you to get scrap paper out before the class, so, or a notebook. Please take notes on this. This is very important, okay? So not only do you use this method to solve just a single variable linear equation, you also use this to solve a multivariable linear equation, okay? And then later on, we'll also use this method to solve systems of linear equations. So, let's see. Who can provide an example? Who can provide an example for us to try and solve? Okay, so let me pick one out of here. Okay, Carney says 4x plus 10 equals x times 20. Okay, 4x plus 10 equals 20x. Okay, that is the example. So let's solve this linear equation. Now, when we solve linear equations, we use this thing called an inverse operation. Okay, inverse operations. We use those to solve linear equations. Now, inverse operations are the reverse operation or the opposite operation of another operation. Okay, so let's say minus symbol. Okay, the inverse operation of that would be addition, right? Okay, and then let's say multiplication. Inverse operation of that would be division, right? So those are very basic inverse operations. And also when we use exponents later on, but not today, those are kind of hard to solve. So we're not going to do exponents today, but the inverse operation of exponents, let's say the inverse operation of a square is square root, right? So that's a basic explanation of inverse operations. Now, how do we use inverse operations to solve linear equations? So the goal of solving a linear equation is to isolate x on one side, okay? And all the numerals, all the other variables on the other side, okay? So the finished product should equal x, should be x equals some number, okay? So the finished product is always this when you're solving single variable linear equations. So we have to isolate x on one side and then all the numerals, all the numbers on the x other side, and then we get this finished product over here. So let's try solving this example Carney gave us, okay? So we need to isolate x, right? So we've got x on this side and x on that side, right? Got 4x and 20x. Now, to remove x from one side, let's say we want to remove 4x from this side, okay? We want to remove 4x on this side and move it to this other side. We want to isolate x on one side, right? So how do you move this x? Okay, so we use inverse operations. Right now, we have a positive 4x over here. And when you move it to the other side, it becomes a negative 4x, okay? So once you move it, it'd be 20x minus 4x, which equals 16x, okay? So why do we have to minus 4x? Why does it turn into a negative? Well, we want to cancel out 4x on this side and move it to where 20x is, right? And how do we cancel out a positive 4x? We simply have to do the inverse operation of it, negative 4x. And if this side subtracts 4x, then this side also has to subtract 4x, okay? So that is where we get our next stage right here, okay? We get this next stage, okay? So usually, the x is on the left-hand side, So let's move that real quick. Easy fix. And then to solve for x, we just need 1x, right? We don't need 16x. And what is the inverse operation of multiplication, right? X is being multiplied by 16. X is being multiplied by 16. Okay, and do the inverse operation of that, you just divide by 16. Just divide by 16 on both sides because you have to keep it equal, right? This is an equation. You always have to keep it equal. You divide on one side, you divide on the other. You multiply one side, you multiply other. Okay? So now we just divide both sides by 16 to get 1x. Okay, just x. Now, okay, these 16s cancel out on the left-hand side. What about the right-hand side? Okay, we get this fraction. And this fraction, you don't need to turn into a decimal. You can just leave it as it is. Okay, just leave it as it is. But this one, you can simplify, right? So always simplify if necessary, okay? Okay, so we get x equals 5 divided by 8, okay? 5/5. So that is how you solve a linear equation. Okay. So now let's do some practice with a linear equation, okay? So let's do some practice. Okay? So the first problem is -5 times the quantity of 3x minus 4 equals 5, okay? So please try and solve this linear equation on your own. And this linear equation is using the making use of the distributive property, which I'm sure all of you have learned in 4th grade or 5th grade, okay? So please solve this linear equation and put your answer in the chat box. Okay, so please try to solve this. Okay. Steven says x equals 1. Okay. Any more answers? Okay, very quick work, Steven. And then Carney says -8x equals 25. Okay. Yes. Please divide. And then Jocelyn says x equals 1. And Reza says x equals 1. So we have a lot of 1s here. Okay? So any more answers? You guys have very quick answers, so very good job on that. Yes, you need a lot of speed. For example, if you go to a mathematics contest, then you will need a lot of speed. Okay. Okay, so Steven says x equals 1, and then x equals -8 over 25. Okay. And then 5 over -3, and then some other answers. Okay. So let me walk you through this now. Okay, let's solve this together. Remember, in the distributive property, you have to multiply -5 to every number in the parentheses. So let's just do that. So -5 times 3x would be negative 15x. And then negative 5 times negative 4 would equal 20, positive 20, right? A negative times a negative equals 20. Okay, negative times negative goes positive. Okay, so a lot of people fail to notice this negative sign. So you might have written it as negative 20, okay? So please don't miss that negative sign. Very important, okay? And then we have 5 on this side. So remember inverse operations. Remember, you have to move 20 to this side, okay? And then isolate x, right? Move 20. Remember inverse operations, okay? Don't forget inverse operations. So remember, you have to minus 20 instead of adding 20, okay? So minus 20. And the next stage would be negative 15x equals negative 15. Now this is very easy, right? And then you just divide both sides by negative 15, and what you get, okay, x equals 1. Okay, so a lot of you got 1. Very, very good job. Congratulations. And some of you probably forgot inverse operations. So, okay. Okay, Gemini, you just got here. Okay. We were doing this problem over here, okay? So, Gemini, do you know how to solve these problems? Do you need me to go over the concepts, or do you or can you solve it on your own? We haven't gone very deep into it yet, so okay, you can solve it on your own. Okay, so let's move on. 6y minus 8 equals 2 times the quantity of 3y minus 4, okay? So that is another problem with distributive property. So make sure you don't forget inverse operations or do distributive property wrong this time, okay? So always double check your stages, because there's one little mistake can turn into a big mistake once you're done, okay? So be sure to double check your answers after you're done. So this is number 2. Let me read it out loud again. 6y minus 8 equals 2 times the quantity of 3y minus 4, okay? So please put your answer in the chat box, and if you have any questions, put it also in the chat box. Then once I walk you through it at the end, I will solve the equation and answer your questions. Okay? So please put your answer in the chat box. I'll give you a few moments. Okay. I'll give you a few more moments to solve this. So I'll leave the slide up, and you guys can solve it. And please put your answer in the chat box. Okay. So, any questions? There are not a lot of answers yet. There is a y equals 0, and then I think there's a y equals 1. Okay. So let me walk you through it now. So this is pretty similar to the previous problem, just a distributive property over here. So, okay. So let's multiply 2 to every symbol or quantity in the parentheses, okay? So 2 times 3y, 6y, and then 2 times -4, -8, okay? And there we go. We have our first stage, okay? And you might notice that we have 6y and 6y on both sides, right? So if you have 6y and 6y on both sides, then they cancel out, right? They cancel out. You don't need them anymore, okay? So get this. Then we have -8 equals -8. And those cancel out. And 0 equals 0, right? Just 0 equals 0. You might think, well, x or y equals nothing, right? Y equals 0. No, that is not the case. This is what is called an identity solution. Okay, so at last you get -8 equals -8, right? So both sides are identical, right? This is an identity solution. And the solution is all real numbers. When you get both sides that are identical, the answer is all real numbers, okay? Infinite solutions. All real numbers work. So any value of x would work, okay? So, and identity solutions, remember the schedule. I will talk about identity solutions and go deeper in the next few slides. So if you don't understand, I'll go deeper on identity solutions. But this is our first identity solution, and the solution would be all real numbers, okay? All real numbers. So, let's go to number 3. Okay, number 3. So this is a bit harder, okay? Very, bit harder than the last ones, okay? This one is 4/5 times n plus times the quantity of n plus 1 equals 3n minus 6. So please try to solve this. Okay, so this is a bit harder. But please don't forget inverse operations, okay? There is a way to simplify this without fractions, okay? So once you figure out that method, it becomes very, very easy. So don't forget inverse operations. This will help you a lot during this equation, okay? Okay, I'll give you a few moments to solve this one, and please put your answer in the chat, okay? Okay, so let's see. This one, okay, Jocelyn says n equals 34 over 11, okay? Very nice, okay? Very nice. Any more answers? Any more answers? Okay. Okay. We also have an answer of 3. Does anyone have any more questions or answers? Okay. Okay. I don't think there are any more answers. So let me walk you through it. Okay. So we have this fraction, okay? We have this fraction. Now, normally, you don't want to deal with fractions, okay? So they're very hard to work with. So what we need to do is to simplify. You have to simplify this, okay? So let me rewrite this equation. Let me rewrite it. And then we don't want this fraction, okay? So let's simplify this. We don't want this 5. We don't want 4 to be divided by 5, right? If 4 is divided by 5, we get a fraction. So we have to cancel out that 5. And how do we do that? Remember, the inverse operation of division is multiplication, right? So we just multiply. We multiply by 5. Okay, but we're not done. We have to multiply 5 on every single term in the equation to keep it equal, right? You have to keep things equal. You multiply on this side, you have to multiply on that side. So we multiply 5 on every term. And we get these two 5s cancel out. Okay. And then let's simplify it. And then on the other side, don't forget to multiply 5 on the other side too. Get 15n minus 30. Okay. And then we can solve. Okay. Distributive property right here. Easy. Let's simplify that. And then on the other side, remains the same. Next stage. Okay. Let's move 15n to the side, okay? 15n to that side. And then 4 to that side, okay? So remember, we have to subtract 15n, okay? Inverse operations. Subtract 15n from the left-hand side, and we get negative 11n, which equals negative 34, right? Yes, negative 34. And then we just have to divide both sides by negative 11, right? We get n equals negative 34 divided by negative 11, which just simplifies to 34 over 11. Okay? So 34 over 11. Okay? Does everybody get it? Okay. So now let's move on to identity equations, okay? And no solution equations. Now, once in a while, we run into these types of identity equations and no solution equations, right? In our second practice problem with linear equations, we ran into an identity equation, right? Okay, so now let me explain what an identity equation is. Okay, a linear equation that is true for all a linear equation that is true for all possible values of the variable, okay? And both sides are equal when simplified. Okay, so that is the definition of an identity equation. So it's a linear equation that is true for all possible values of the variable. So once you get to this final step, let's say y should equal all real numbers, okay? Infinite solutions, all real numbers, okay? So let me give an example. Let's say 6 plus y equals something like that, right? Once you simplify it all out, you get the same thing, right? You just get y equals y. Let's get y equals y. Or you can get 6 plus 6. 6 equals 6. Not 6 plus 6. 6 equals 6. So those are identity equations. Okay? So once you get down to the final step, you find out that both sides are equal to each other. Okay? They're identical. They're identical. Okay? And then what is the solution if they're both identical to each other? Well, then the answer would be all possible values for the variable, or all real numbers, okay? All real numbers. And then we have no solution equations. Identity equations, the solution is all numbers, right? And no solution equations don't have a solution, okay? So 0 numbers. And the definition of a no solution equation is a linear equation that is impossible to be true no matter what the variable equals, okay? So it's impossible to be true. Let's say y plus 6 equals y plus 4. Then you cancel out y, and you get 6 equals 4. You just get 6 equals 4, right? So that is not a true statement, right? That's false. 6 cannot possibly equal 4, okay? And then that would be a no solution equation. And then you just simply write no solution. Or you can say no values or 0 values, okay? So those are identity equations and no solution equations. So now let's do some practice with those, okay? So this is our first practice problem. I'm not going to tell you if this is an identity equation or a no solution equation, okay? So please find out if this is an identity equation or a no solution equation. Also write the final step, okay? So in the final step it should be something equals something, okay? Should be identical sides, or it should be something is not equal to something, okay? Then it'd be no solution. Okay, so please put your answer in the chat box. I'll wait for your answer. I give you a few moments. Okay. Jocelyn says no solution. Steven says identity. Okay. Jocelyn says -2 equals -6. Eric says no solution. Okay. So let's wait for some other students to answer the question. Okay. Let's see. So here is the slide. Okay. Please answer this. And I'll give you a few moments to try and solve this. Okay. So a lot of you said no solution. So let's solve this. Okay. Let's try to solve this. Okay. So actually this fraction, right? We don't need to simplify this because both 6x and -4 can be multiplied by 1/2 evenly, okay? So 6x times 1/2 would equal to 3x. And then -4 times 1/2 would equal -2. So, okay? That'd be our first left-hand side. Okay. So let's solve for the right-hand side. Okay, so let's just simplify this these parentheses. Okay. So there we go. And then look, 3x cancels out, right? And then we get -2 equals -6. Okay, we get -2 equals -6. Now that is not true, right? So what is that? That is a no solution equation, okay? No solution. Very good. A lot of you got no solution. Congratulations. And now let's solve this equation. This should either be an identity or a no solution equation. So please try to solve this on your own. Okay. Number 2. Please solve that and put it in the chat box. I'll give you a few moments to try and answer. And also, when I go and check the answers, some people may not be done yet. So I'm sharing my screen, and once I go to the chat, you can't see my screen, right? You can't see the question. So it'd probably be wise to copy down the question first. So when I go and check answers, you can still see the question, okay? Okay. Please solve this equation. Okay. There are a few fractions in here. But yeah, I think you can simplify these ones. Okay. Are there any answers? Okay, so we have one identity and one no solution, okay? So let me walk you through it now. Okay, so -5, remember, let's do this distributive property first. -5 times x divided by 15 would equal to -5/15x. Okay, and then remember, we have a -5 multiplied by negative 16. So remember that turns into a positive 80. Okay, turns into a positive 80. Okay, and then we have this negative 30. Okay, so let's simplify this. 80 minus 30 equals 50. Okay, we can simplify that real quick first. Okay, and then we have another 50 on this side, and then a negative 1/3 x. And let's see. This cancels out, right? We have the 50s just cancel out. And then we get negative 5 over 15x, and then equals negative 1/3 x. And what is this? These fractions, negative 5 over 15 and negative 1/3, they're equal, right? They're equal. So this would actually be an identity. This would be an identity equation. Okay. Does everybody get where I'm coming from? Okay. And Eric says, I forgot a 30. Actually, I simplified the 30 already because negative 5 over here multiplied by negative 16, that equals to plus or positive 80, and then minus another 30. I just simplified it to 50 real quick. Okay, so I did not forget that 30. And also, let's move on to arranging multivariable equations. Okay, so these topics in the schedule, they're all interconnected. Okay, so the method I taught you maybe a few subjects ago can be used to solve these subjects. Okay, so the tip for arranging multivariable equations, let's say we have a b equals t divided by s. Okay, and how do we arrange the multivariable equation? So when you're arranging multivariable equations, you want to, let's say, solve for one variable. Okay, you have to solve for one variable. Let's say solve for t. Okay, solve for t in this multivariable equation. Okay, solve for t. And I give you a little tip here, and this is the exact same tip that I gave you when we started doing single variable equations, right? You just have to isolate the variable you are solving for on one side. We're solving for t, right? And all the numbers in all the other variables on the other side. Okay? So you just have to isolate t on one side. And let me show you how to solve that. Let's have our little equation here. And we just have to isolate t, right? And how do we get t away from this s? Inverse operations. Just have to multiply. Multiply by s on both sides. Okay, and then these s's cancel out. And then we get ds equals t. Is that correct? Yes. Okay. That is how we rearrange these multivariable equations. Okay, so now let's practice a bit. Okay. Okay. Actually, let's do some more warm-up examples first. And also, I want to show you an example in a practice problem later. So when we're trying to arrange multivariable equations, sometimes you see this dx plus f x equals ts. Okay, so solve for x. solve for x. We just have to isolate x, right? But look, okay? X is multiplied by d and f, right? Now, how to isolate x from these two variables, okay? How do you separate d and f, okay? How do you separate them? And there's this thing called factoring, okay? You factor. So let's find a common factor of d and f. A common factor of dx and fx, okay? The common factor is x, of course. Both of them are multiplied by x, and then we can factor into this. We're basically just doing the distributive property backwards, right? We're just doing distributive property backwards. And then we get this. This is much more simpler, right? But we're not done yet, okay? The next stage would be x equals ts divided by d plus f, right? Because we don't want this whole huge thing, okay, on the left-hand side. We just divide by the whole thing, okay? We just divide by the whole thing. And at last, we get this, okay? We get that. So does everybody understand how we use factoring to solve this multivariable equation? Okay. You got it? Good. Oh, Eric says, no. Okay, Eric. Where do you not understand? I'll explain it again for you. Okay, so please put in the chat if you have any questions or if you don't understand, okay? So Eric says he doesn't understand. So Eric, where do you not understand? Now go over it for you. Okay. Well then, let's move on to some practice problems. Okay? Let's move on to some practice problems. So number one is solve for t. Solve for t. Okay? Just isolate t on one side and all the other variables and all the other numerals actually aren't any numerals in this equation. So please try and solve for t, okay? Solve for t. And rearrange this equation. Okay. T equals ds divided by gp, okay? So that is what Jocelyn says, okay? That's the only answer I've received so far. And also, Oliver asks, what grade is this? This grade is 7th grade, okay? 7th grade. And we are solving for t, okay? Solving for t. Okay? This is actually 7th grade material. This is but this will be very easy, okay? For some of you are very ahead of your classes, so this should be no problem, okay? So I learned this like 2 to 3 years ago, right? Very, very easy if you know the concepts, okay? I know a lot of you are very talented, okay, and very ahead of your classes, right? So all you just need to do is, you know, the distributive property variables. You just need to know about inverse operations, and then you can solve linear equations. It's just understanding the concepts, okay? Okay. Yes, I am going to send the recording. I'm going to post it on YouTube, Eric. Then I'll put the YouTube link in the group chat later. Okay. And also, be sure to check out my YouTube channel. I already have 3 videos already. Okay. And then let's solve this. Okay. Let's isolate t. Let's isolate t on the right-hand side. Okay, first we need to get rid of this s, okay? We multiply s on both sides, okay? And then we get ds equals gp plus t, okay? Okay? And then we are one step away from the answer, okay? We have this gp here. We need to get rid of that. Get rid of that. We just need to isolate t. And then this is a positive gp, right? Then we just have to use inverse operations. Then do ds minus gp. You have to subtract gp on both sides, right? And then ds minus gp equals t. That is our answer. Okay? That is our answer. Does everybody understand? Okay, very good. My YouTube channel name is just my name, okay? And also I'll be sure to post the link to my channel in the group chat later, okay? In WeChat, okay? And then let's solve this. The next one. Okay, this one uses factoring, right? Okay, this one uses factoring. Okay, so this one we're solving for x. Okay, so pay attention. We're not solving for d. We're not solving for f, or we're not solving for g. Okay, we're solving for x on this one. Please solve this one, and I'll give you a few moments of time. Okay, few moments, and then post your answer in the chat box. Okay, post your answer in the chat box. Okay. So, a lot of answers. We have x equals d divided by f plus g. And then we just have a d equals f divided by g. And then we have a d divided by f plus g again. And someone asked what grade am I in? I'm in 7th grade, but I'm learning. Well, I am in 7th grade, but I'm learning high school mathematics. I'm taking Algebra 1, which is a high school course, but I'm still in middle school. But okay. Let's solve this one, okay? And when you're in middle school, I'm sure you'll probably solve, like, when you're in 7th grade, you're probably solving 8th grade or high school math, okay? Algebra 1 is still very easy for me, but okay. So let's do this problem. We have factoring, right? The common factor of x, fx, and gx is x, right? So let's factor that out. X times the quantity of f plus g, okay? And then that equals d. And then, very easy, we just divide f plus g. We just divide the whole thing. Then we get x equals d divided by f plus g, okay? So that is our answer. Okay, so a lot of you got that correct. And very, very good job. Okay, you guys have a very good understanding. Okay, and that is our last problem. Okay, that is our last practice problem. And this is the end of my class for today. So thank you for listening, everyone. And don't forget to like and subscribe.